This is Grade 6 Math, Chapter 1.5, Cubes and Cube Roots. There are three main ideas in this chapter. The first is to find a cube of a number. The second is to find a cube root of a perfect cube. And the third idea combines what we learned in Chapter 1.4 with what we're learning today in Chapter 1.5 and asks us to evaluate numerical expressions involving whole number exponents, meaning squares and cubes together. Let's get started with today's problems. Let's start by finding a cube of a whole number. I'll warn you also that you're about to enter the portion of math where you will be introduced to my questionable artistic skills, but go with it, trust the numbers, not what my lines look like. Okay, so we're going to start with this problem. A cube has edges 2 centimeters long. Find its volume. Now you'll recall we calculate volume by taking length times width times height. Okay, so in this case, the volume of our cube is 2 times 2 times 2. All right, 2 times 2 is 4, 4 times 2 is 8, so the volume of our cube is 8 centimeters cubed. I use a 3 there because we've used 1, 2, 3, and multiplied 1, 2, 3, so our exponent is 3. We can rewrite 2 times 2 times 2 as 2 base 2 raised to the exponent 3 to the third power. So we could reread this as 2 cubed. So the 3 again is our exponent, the 2 is our base, and we would read this as 2 cubed. So the cube of a whole number is called a perfect cube. So 8 is a perfect cube because it is equivalent to 2 times 2 times 2. Now let's find the cube of 7. So we can relate this to finding the volume of a cube with edges that have a length of 7. Again, please excuse my subpar drawing. So we can think of 7 cubed as 7 times 7 times 7, because again, remember this exponent tells us take the base times itself that number of times. So 1, 2, 3 sevens equals 7 cubed. So now we calculate 7 times 7 is 49. And 49 times 7, let's see, I'm not able to do that by mental math. If you can, that's great, but I need to work it out. 9 times 7 is 63. 7 times 4 is 28, plus 6 is 34. So 343. The cube of 7 is 343. All right, find these cubes on your own, using whichever technique you prefer, either imagining this as a cube and you're literally finding the cube, or writing it as a base with the exponent 3. Calculate the cube for 5, 6, and 9. Please record these in your notebook. Press pause. I'll be here waiting for cube roots when you get back. Now let's find the cube root of a number. So here we have a cube with a volume that equals 27 centimeters cubed. We want to find the length of each edge of the cube. Okay, we know that the volume of the cube equals edge, or length times length times length. Correct? So let's think of a whole number whose cube is 27. So using your memory of basic facts, what times what times what times itself would equal 27. Well, I'm going to try 3. Because I know 3 times 3 is 9, and 9 times 3 is 27. Aha! So our length of each side is 3 centimeters. So 3 is the cube root of 27. We would write it like this. Once again, it gets that cool sign like a square root. But to show that it's a cube root, we put a little 3 right here. So the cube root of 27 is 3. So finding the cube root of a number is exactly the opposite or the inverse of finding the cube of a number. Instead of taking the number times itself 3 times to find the cube, we need to figure out what number times itself 3 times equals the number we are using for our example. Okay, let's try another technique for finding the cube root. Just as we did with finding square roots, we can use prime factorization to help us find a cube root. So let's find the cube root of 64 following prime factorization. So 64, let's see, we would go to 2 and 32. Bring down our 2. The least prime factor of 32 is 2, which leaves us with 16. Bring down that 2 so we don't forget about it. Least prime factor of 16 is 2, leaving us with 8. Once again, carry these 2's so we don't lose them. 2 times 4. All right, we've got a lot of 2's going on here, guys. And finally, we get to our prime factors, 4, which are 2. So our prime factorization is 2 times 2 times 2 times 2 times 2. I think I said enough 2's there. 2 times 2 times 2 times 2 times 2 times 2. No, I missed one. All right, so how do we use this to find the cube root? Let's give ourselves a little bit more room to work with here. Okay, so we're going to use this to find the cube root by applying that commutative property of multiplication. Once again, remember, it doesn't matter in what order we multiply, we still get the same answer. So can you see 3 identical groups in our prime factors here? Because remember, we want to take something times something times something to give us 64. So we want to find 3 identical sets. Well, I can see right away that we have 3 sets of 2 times 2. Okay, so let's rewrite this as 2 times 2 times 2 times 2 times 2 times 2. Okay, now we can rewrite that as 2 times 2 cubed, right? Because they're all the same, they're identical. So we can write them as 2 times 2 cubed. So 2 times 2 is 4 cubed. So what we're looking for, our cube root of 64 is 4. 4 times 4 times 4 equals 64. Work it out in your head. 4 times 4 is 16. 16 times 4 is 64. Yep, it works. Now try finding these 3 cube roots on your own. Find the cube root of 216, the cube root of 343, and the cube root of 1000. Once again, you can use whichever technique works best for you. You can rely on your knowledge of your basic facts, or since finding a cube root is a bit more complex, you may want to rely on using the prime factorization technique. Use whichever technique works for you. Please show me your work so I understand your thinking. Record your answer in your notebook, and I'll be back to start evaluating some numerical expressions when you are done. Now this gets really fun. We're going to evaluate numerical expressions that contain exponents. Before we begin, here's a quick reminder. You might remember this. Please excuse my dear Aunt Sally. We're going to be working with exponents, so we need to be aware of this E. Remember, P stands for parentheses, E for exponents, MD for multiplication and division, AS for addition and subtraction. So, order of operations tells us that we work with whatever's in the parentheses first, followed by anything with an exponent. Then we complete multiplication and division. Then we complete addition and subtraction, always working from left to right. Okay, let's try a problem and use what we remember about PEMDAS. Let's find the value of 3 squared plus 4 squared. So we'll work our exponents first. That means we need to solve for 3 squared, then solve for 4 squared, and then add those two numbers together. So 3 squared is, that's right, 9. And 4 squared is, that's right, 16. 9 plus 16 equals 25. All right, let's try another. The next problem asks us to find the value of 7 squared times 2 squared plus 3 cubed. Okay, so follow PEMDAS. First, we're going to work our exponents. 7 squared equals 49. Bring down the multiplication sign. 2 squared equals 4. bring down the plus sign so we don't lose it. And 3 cubed equals, 3 times 3 is 9, 9 times 3 is, 27. Okay? Now, following PEMDAS, we need to work from left to right, and we need to do multiplication or division before addition or subtraction. So our next step is to take 49 times 4. Well, I'm going to use mental math to do that. 49 is close to 50. 50 times 4 is 200. I ended up with 4 extra digits by rounding to 50. So 196 is my answer here, plus 27. Now I can complete this problem by taking 196 plus 27 to get an answer of 223. Okay, let's try one more together before you try some on your own. Here we're going to solve for the value of 10 cubed minus 4 squared times 5 squared. All right, think about PEMDAS. We're going to work with our exponents first. 10 cubed equals 1,000. Drop down that minus sign so you don't lose it. 4 squared equals what? 16. Times 5 squared equals 25. Now, following the rules of PEMDAS, we multiply before we subtract. So we have 1,000 minus 16 times 25, which is equal to 400. And now we solve by subtracting for our final answer, which is 600. Finish up your work for today with these 6 sample problems. Please record your answers in your homework notebooks. Please show your work so I understand your math thinking as well. Don't forget to follow the rules of PEMDAS. You're always going to work your exponents first in these cases because we don't have any parentheses, then multiplication and division, then addition, subtraction, always working from left to right. Good luck. I look forward to going over these problems with you tomorrow. Have a great evening.